To make it easier for us to sketch the graph of a rational function, you must know the intercepts, zeros, and asymptotes. Now, Quarter 1, Module 9, we will discuss about the intercepts, zeros, and asymptotes of rational functions. Do not forget to subscribe and click the notification bell. X and Y intercepts. The intercepts of the graph of a rational function f of x are the points of intersection of its graph and an axis. The y-intercept of the graph of rational function f of x, if it exists, occurs at f of 0, provided that f of x is defined at x is equal to 0. To find the y-intercept, we let x is equal to 0 and solve for y or f of x. Example, find the y-intercept of f of x is equal to 2x plus 1 all over x minus 1. To find the y-intercept, again, we will let x is equal to 0. Then we will substitute the value of x to the given function. So we have f of 0. Then simplify. Then f of 0 is equal to 1 over negative 1, or it is equal to negative 1. Therefore, the y-intercept is 0, negative 1. Always remember this, that the y-intercept is a point. So you must always write the y-intercept as an ordered pair. The x-intercept of the graph of a rational function f of x, if it exists, provided that f of x is equal to 0 or y is equal to 0. It is also called zeros of a function. To find the x-intercept, we'll let f of x is equal to 0 or y is equal to 0 and solve for x. Example, find the x-intercept of f of x is equal to 2x plus 1 all over x minus 1. Let f of x is equal to 0. That is the first step. Then, from the given function, we will now substitute our f of x to 0. So we have 0 is equal to 2x plus 1 all over x minus 1. Then we will now multiply both sides of our equation by the LCD, and the LCD is x minus 1. So let us start with the left side of our equation. So in simplifying, x minus 1 times 0, so we have 0. Then, on the right side of our equation, 2x plus 1 all over x minus 1 times x minus 1, so we can cancel out x minus 1. So we have 2x plus 1. Then to solve for x, we need to transpose 2x on the other side of our equation, or on the left side. So we have negative 2x is equal to 1. Then divide both sides by negative 2 to solve for x. Therefore, x is equal to negative 1/2. Therefore, the x-intercept is negative 1/2, 0. Always remember that the x-intercept is also a point. Let us now plot the intercepts that we have obtained. So the y-intercept, the coordinates are 0 and negative 1. So in plotting this point, so you have observed that the point is on the y-axis. So this is the y-intercept, because the y-intercept is a point on the graph that crosses the y-axis. The x-intercept with the coordinates of negative 1/2 and 0. So you have observed that our x-intercept is on the x-axis, because the x-intercept is a point on a graph that crosses the x-axis. Asymptotes. An asymptote is an imaginary line to which a graph gets closer and closer as the x or y increases or decreases its value without limit. There are different kinds of asymptote. The first one is the vertical asymptote. So the vertical asymptote, so it looks like this. So you have observed that if we're going to sketch an asymptote, it is always a broken line. It means that your graph will never intersect to this line or to this broken line. Your graph will getting closer and closer to this line, but it will never touch or intersect. We have also the horizontal asymptote. This is now a horizontal asymptote. It is also a broken line. We have also an oblique or slant asymptote. See, it looks like this. So it also a broken line. Let us find the vertical asymptote of the given rational function, and if it is in the form of f of x is equal to ax minus b all over cx minus d. So you have observed that in this form, both numerator and denominator are linear functions. For example, we have f of x is equal to 2x plus 1 all over x minus 1. Now, to find the vertical asymptote, it is just the same on how we find the domain of the given rational function. If you can still recall the domain, we're going to find the restriction of the value of x in the denominator. So since the denominator is x minus 1, it must not be equal to 0, and the value of x that will make our denominator is equal to 0 is 1. So therefore, x must not be equal to 1. So the domain is a set of x such that x is an element of real number, but x must not be equal to 1. Okay. While the vertical asymptote, it is just the same process, but the difference is that we need to find the value of x that will make our denominator is equal to 0. Okay. It means that instead of using not equal, we will use equal sign. So x minus 1 is equal to 0. And so for x, x is equal to 1. Therefore, we can say that the vertical asymptote is x is equal to 1. So it is a line. So since it is a line, it must be a broken line. To find the horizontal asymptote of the given rational function, f of x is equal to 2x plus 1 all over x minus 1. So if you can still recall on how we get the range of a rational function if we have both numerator and denominator have the same degree. So the range is a resection of y in which y is not equal to a over c, where a is the leading coefficient of your numerator and c is also the leading coefficient of your denominator. Then substitute the values of a and c. So we have y is not equal to 2 over 1 or y is not equal to 2. So therefore, the range is a set of y such that y is an element of real number but y is not equal to 2. So the same process in finding the horizontal asymptote of the given rational function. So at this time, we're going to find the value of y, which is y is equal to a over c. Then y is equal to 2 over 1. Then y is equal to 2. Therefore, the horizontal asymptote is y is equal to 2. Since we already obtained the asymptotes of the given rational function, let us now sketch these asymptotes to the Cartesian plane. So let us start with the vertical asymptote. So the vertical asymptote is x is equal to 1. So we're going to check in the x-axis kung asan yung x is equal to 1 natin. Then we will now draw a broken line, a vertical line. And that is a broken line. So this is now your x is equal to 1. Then we also have the horizontal asymptote. which is y is equal to 2. So we're going to check in our y-axis. So allocate y is equal to 2 and draw a broken line, a horizontal broken line. So this is now our horizontal asymptote. So this line, it indicates that the graph of the given rational function is getting closer and closer to this horizontal line. So let us discuss further about the horizontal asymptote. So how about it is in the form of f of x is equal to ax raised to n plus bx plus c all over dx raised to m plus ex plus f. You have observed that the numerator is now different degree to the denominator. To determine the horizontal asymptote of a rational function, compare the degree of the numerator n and the degree of the denominator m. Let us recall, the degree of the numerator is the highest exponent of the variable x in the numerator, and the degree of the denominator is the highest exponent of the variable x in the denominator. To make it easier for us to determine the horizontal asymptote of a rational function, so we will now compare the degree of the numerator, which is n, and the degree of the denominator, which is m. If n is less than m, then the horizontal asymptote is y is equal to 0. If n is equal to m, then the horizontal asymptote is y is equal to a over d. Now observe this. Your a is the leading coefficient of your numerator, while your d is the leading coefficient of your denominator. If n is greater than m, then there is no horizontal asymptote. Let us try this. Determine the horizontal asymptote of each rational function. So let us start with number 1. So first, we need to identify the degree in the numerator. So you have observed that the highest exponent of x is 1. Therefore, the degree is 1. Then, the denominator, the highest exponent is 2. Therefore, the degree is 2. Then we can now apply, since n is less than m, then the horizontal asymptote is y is equal to 0. Let's proceed to number 2. So, what is the degree of the numerator? Okay, very good. The degree of the numerator is 2, while the degree of the denominator is? Okay, very good. Still 2. So since you have observed that n is equal to m, then the horizontal asymptote is y is equal to a over d. Since the leading coefficient of your numerator is 2 and the leading coefficient of your denominator is 1, therefore, the horizontal asymptote is y is equal to 2 over 1, or it is equal to 2. Okay, next, the degree in the numerator is 2. Then, the degree of the denominator is 1. So what have you observed? You have observed that n is greater than m, then we can say that there is no horizontal asymptote. So in example number 3, there is no horizontal asymptote. Another example. Let f of x is equal to x minus 8 all over 2x plus 2. Find a, y-intercept, b, x-intercept, c, vertical asymptote, d, horizontal asymptote. So let us start with the y-intercept. So in finding the y-intercept, we let x is equal to 0. Then substitute the value of x to the given rational function. So we have f of 0. Then simplify. f of 0 is equal to negative 8 over 2. And we can still simplify this to its lowest term. Therefore, f of 0 is equal to negative 4. Then, the y-intercept is 0, negative 4. The x-intercept. We let f of x is equal to 0. Then substitute f of x, the value of f of x, to the given rational function. Then we have 0 is equal to x minus 8 all over 2x plus 2. Then multiply both sides of our equation by the LCD. And the LCD is 2x plus 2. Then we will now multiply and simplify. So we have 0 is equal to x minus 8. Then after that, we can find the value of x by transposing it's either a constant or the variable to the other side of our equation. At this time, I will transpose negative 8 on the other side. So we have 8 is equal to x. Therefore, or it is just the same, x is equal to 8. So the x-intercept is 8, 0. Now, the vertical asymptote. To find the vertical asymptote, we need to get the denominator of the given rational function. Then we will equate this to 0. Then solve for x. So you have 2x is equal to negative 2 because we transpose positive 2 on the other side of our equation. Then we divide both sides of the equation by the coefficient of x, which is 2. Then simplify, x is equal to negative 1. Therefore, the vertical asymptote is x is equal to negative 1. And lastly, the horizontal asymptote. To find the horizontal asymptote, since you have observed that the given rational functions, they have the same degree. Both numerator and denominator are degree of 1. Therefore, we will now apply y is equal to a over c. Then, the value of a is 1, which is the leading coefficient of the numerator, and the value of c is 2, which is the leading coefficient of the denominator. Then, the horizontal asymptote is y is equal to 1/2.